Hi everyone, in this video we'll look at how to convert NFA to DFA, and let's take the example that I already have written here, which is binary strings ending with 0 and the regular expression is 0 plus 1 star 0. So let's quickly draw an NFA for this, and the way I would do that is I would have a start state which is Q0, and on 0 or 1 Q0 just loops to itself. So this is on 0 or 1, and then on 0 it goes to Q1, which is my final state. So it goes to Q1 right here. And now I remember that NFA don't need to have all arrows basically, so I'm not going to be drawing any arrows from Q1 right here. So let's go ahead and try to convert this to a DFA. The way we do that normally is we use a table, and the first thing I'll write here is Q0, which is my start state, and then I need to see where it goes on 0 and where it goes on 1. So on 0, where does Q0 go? It goes to Q0 as well as Q1, so it goes to two states. So what I do is I write both of them together, and this is going to be a new state in my DFA. So the way we create states in our DFAs is by merging states from our NFA. So I have Q0, Q1 right here, and where does Q0 go on a 1? It just goes to Q0 itself. So next what I do is I don't write Q1 right here. Instead I write whatever states have come in my table on these two columns, so here and here. So the new state that has come up is Q0, Q1. That's what I'm going to be writing here. So I write Q0, Q1 here. And where does Q0, Q1 go on a 0? So the way I evaluate this is by looking at where does Q0 go on 0. So Q0 goes to Q0 itself and it goes to Q1. So I write Q0, Q1 here. And where does Q1 go on a 0? It goes nowhere. So I don't write anything after Q0, Q1 right here. I just leave it blank. So the state that Q0, Q1 goes to on a 0 is Q0, Q1 itself. And where does it go on a 1? So where does Q0 go on a 1? It goes to Q0 itself. And where does Q1 go on a 1? It doesn't go anywhere, so I leave this part blank as well. So where does Q0, Q1 go on a 1? It goes to just Q0. And now I'm ready to draw the DFA for this. So let's go ahead and draw it at the bottom here. So I first have a state Q0. These are the states that I'm going to be drawing. So these are states in my DFA. Sorry about the handwriting. So these are states in my DFA. So Q1 is going to be my start state. And one thing that I've actually forgotten in the table is to evaluate what the final state is. So my final state in the original NFA was Q1, which was this thing right here. Maybe not a great idea to draw a circle there, but Q1 is my final state in the NFA. So wherever I have Q1, so here I don't have a Q1, so this is not final, but here I do have Q1. So this is going to be a final state. So next I come back to my DFA. So I have Q0, which is my start state, and I have another state which is my final state, and that's going to be called Q0, Q1. So this is Q0, Q1. So from Q0 on 0 I go to Q0, Q1. This is on 0. On 1 I stay at Q0. So this is on 1. And from Q0, Q1 on 0 I stay at Q0, Q1. And on 1 I go back to Q0. So this is the final DFA that I get by converting the NFA above. So this is basically how we convert NFA to DFA, but let's take a look at another example. So here's an NFA that we already looked at in the previous video. So I have a state Q0, which is my start state, and the string pattern that I'm actually aiming for is all strings that end with 0 or 1, and the only string that's not going to be accepted is epsilon. So I have two epsilon transitions here. So these are epsilon transitions to Q1 and let's say Q3. And Q1 on a 0, it goes to a final state which is Q2, and Q3 on a 1, it goes to a final state which is Q4, and on 1 Q1 retains state, on 0 Q2 retains state, and on a 1 Q2 comes back to Q1, and in the DFA, in the states at the bottom, I have from Q3 I retain state at 0, and Q4 retains state at a 1, and Q4 comes back to Q3 on a 0. So this is the NFA that I have, and if you want you can actually try and pause this video, try to come up with the DFA. We've actually already done that in the previous video. So the way I do it this time, there's one slight difference right here. Instead of just writing Q0 here, I'm going to be writing Q0, Q1, Q3. And the reason I'm doing that is because my start state is in my DFA is not just going to be Q0, because from Q0 I can go to Q1 and Q3 with no input. So this is actually called the epsilon closure of Q0. So the epsilon closure of any state is the set of states where I can go on an epsilon input, and that's always going to contain the state itself. So the epsilon closure of Q0 will contain Q0 as well. So my start state is now Q0, Q1, Q3, and where can I go from there on a 0, and where do I go from there on a 1? So on 0, where does Q0 go? It goes nowhere. Where does Q1 go? It goes to Q2. So I write Q2 right here. Where does Q3 go on a 0? It just stays at Q3. So I have a new state which is Q2, Q3. And on 1, where does Q0 go? It goes nowhere. On 1, where does Q1 go? It goes to Q1 itself. Where does Q3 go? It goes to Q4. And now the new states that I'll have to write here are Q2, Q3. And I'll also have to write Q1, Q4. So where does Q2, Q3 go on a 0? I'm just going to directly write the answer. See if you can make sense of it. So it goes to Q2, Q3. And where does it go on a 1? It goes to Q1, Q4. And where does Q1, Q4 go? On a 0, it goes to Q2, Q3. On a 1, it goes to again it goes to Q1, Q4. So it retains state. So this is the table that I have, and I can easily draw my DFA with these three states, which would be Q0, Q1, Q3, Q2, Q3, and Q1, Q4. All that's left is to determine the final state. So my final states here were Q2 and Q4. So wherever I have Q2 or Q4, I'm going to make that a final state. So this is going to be a final state, and this is going to be a final state. And this is of course my start state, which is Q0, Q1, Q3. So this is how we convert NFA to DFA. I hope all of this is clear. In the next video, we'll take a special case of this conversion where we have something called a trap state or a dead state. So we'll see that in the next video. I'll see you there.